Well, welcome back. What we're going to do now is continue on with our HTTP slides and talk about status codes and a little bit beyond. So I've been kind of throwing 200 OK at you recently. Basically, this is the response the server is sending you based on whatever your request was. All right. There are some common response codes, which pretty much every web developer will burn into their memory by the time they're done debugging their first application. There are a lot of standard ones. You can send your own response code as well if you want, but effectively the purpose is for you to understand what's going right or wrong with your request. Now, 200 means everything's fine. Here's your response. No worries, everything is good. The format of the actual message, though, is first, what's the version? What's the status code? What's the explanation? So if we come back here to our CIS page, and I look at my header, status code 200, OK. So our status code is 200, explanation, OK. The Chrome tools here are abstracting out the HTTP version here, but we have that elsewhere in our packet. So common categories, which you will probably see at some point or another. The 100 level are mainly going to be informational. So if your server has some kind of a generic response, or if you want to override some response code that is specific to your application, whatever you want to do here. Basically, not super widely used. You don't often see those when applications go down, but they are there if you want to provide information to, say, the client. Now, um, status code 200. This is going to be success of some kind, right? I've got XX in here as well because we can have more than just 200. You could have 201, 205, 210, 299. All of these are going to be success codes. Keep in mind that these status codes, they're up to you as the developer. So kind of like if you're programming a normal application and you give it a function, a return value, return 0, return 1, return true, return -1. This is completely up to you. We'll use common codes, but if you have a web application or if you're configuring your server in a particular way, you can return whatever code you want. Just we have common codes, right? So 300 level, we're going to tell the client to do something else, okay? Redirect, do a different request. Basically, something is off. We are handling the client in this way. 400 level, there's going to be an error with your request, so you screwed something up in some way. Possibly we did as the server, but something's off. Maybe your query is malformed. Maybe you have an issue with one of your parameters. Okay, maybe a page isn't found. I've got this example here. Very common one, 404, page not found. What is this? It means that whatever resource you're trying to access doesn't exist on the path you are telling it. If I want efredericks.net/about and I try to go there and I get a 404 error, it's because I didn't define about in the location the server is expecting. Maybe it's in efredericks.net/pages/about. Then you get a correct return code. All right, 500 error, you're going to see something probably like this. It means you have an issue with a server-side script. Pretty commonly, you have a bug in your PHP or in your React or in your .NET code, something like that, and your server just kind of dies. In this case, you probably are going to look at the logs from your server to see what went wrong. Okay, so common status codes for us. These are the ones you probably know. 200, okay, everything's good, nothing to worry about. 300, moved permanently. This is where we're telling our client to do something else. Okay, we're going to redirect you to wherever the new address is. Maybe we had a reorganization of our web server. All of our old pages are now in a new location. We can redirect the client in that way. You could also use this to, say, redirect a client from one web host to another if you want to. I actually do this to redirect my GVSU profile to my self-hosted one. Actually, I can show you that. So let's pop open our network. Let's go to cis.gvsu.edu/Frederick. So it redirects here, right? But what I should see is I get a 302 response, meaning send me elsewhere. All right. Or sorry, 301 move permanently, then 302, and then to my actual server. All I am doing code-wise is I'm sending a header in PHP that it's moved, and it's giving me this 301 move permanently error. Not an error, it's a return code. Okay, these are common ones. Here's our common error codes. So 404, we've talked about, your resource can't be found. You have a path wrong, or the server is misconfigured to, maybe it's like permission denied type thing. 500, again, syntax issue with one of your scripts. 403, forbidden, also possible with permissions error. Basically, you are not allowed to access this resource on the server. Common issues with this would be if you're running an Ubuntu server like we all are, and you basically lock the file behind, maybe a different username other than the Apache user, or you set its permissions to be not readable by anybody. So, common status codes, again, get used to these, you'll be seeing them quite often. Okay, back again. Sorry, I had to hydrate. What we're going to talk about now are some of the different header categories that we have. So if you were eagle-eyed, you may have noticed that in our dev tools, we actually have different categories for headers. So request, general, response. The idea here is that the general is going to be common to both the request and the response. And then obviously, these are going to be specific to their own type of thing. So for request header, typically you're going to see things related to the client. What's the user agent? What's the host we're looking for? What is our referrer? So here, if we look at our request, we can see user agent, Mozilla 5.0/Chrome/Safari. Basically, here is what our browser probably is. Not as a big of a deal anymore, but this was a massive issue with the web for a while, where you would have to figure out who was browsing your website and target your development efforts appropriately because every browser will render things differently. Again, not as big of an issue today as browsers have kind of standardized how they parse out HTML. But you could look at, I mean, even today it's possible, but you can look at one website in Chrome versus Firefox versus Internet Explorer versus Edge versus Safari, and it's going to look subtly different at times. Now, again, not as big of an issue today with a lot of standardization in these unifying libraries we have, but this was a big issue for web developers for the longest time. And if you're one of those developers that has to support legacy applications, I feel really bad for you. But again, useful to understand who's browsing your site. All right, refer. So what are we looking for? Or sorry, where are we coming from? Contact us. What are we looking for? cis.gvsu.edu. Okay. For a response header, we're going to get information from our server. So response header, server was Apache, encoding was chunks. When does this thing expire? What's the content type? Is our connection open or closed? Basically, specific things for the responses. And then actually talking about the content itself, we can look at its length, we can look at its type, basically what is inside of this packet. All right. Now, I keep talking about the content type, MIME types. These are terms I've been throwing around. Basically, these are ways of describing what the information in your resource is. Now, typically, we are going to have, images, HTML code, JavaScript files, but it could be any supported MIME type. Now, I've got a link to all the different ones out there. Again, these are some of the more common ones. Text/plain could be just random text. Is this a CSS file, a JavaScript file, HTML, images, videos, so on and so forth, right? Basically, the idea is we need to tell the client what type of data they need to parse out. Also, they need to understand, is it encoded? Is it compressed? How do we decompress it, right? Effectively, how do we parse out this blob of data that we are receiving as a browser? We also might have to deal with multi-part data. So is this form information? Is it a file? basically there's a lot of things to consider here. And really, just to kind of summarize what you need to worry about, what type of information is it, right? And this is not as common anymore with HTML5, but for the longest time, if you wanted to write a script or CSS code, you would have to actually specify this in your actual language. So if I were to say, just give you a quick example here, let's make this a touch bigger. I never remembered to actually set defaults for Vim, not sure why. If I were to say make a web page, say HTML, and I'm going to start writing some JavaScript code. Okay, I'd have to do something like this: script type equals text/JavaScript. And this was required for a while. Not required anymore. Now you can just say script and that's it. Or I'd have to do style type equals text/CSS. All right, so this stuff here, this stuff here is going to be my MIME type. We used to have to tell browsers this before they understood that by default, script is probably going to be JavaScript, right? You still have the option. It's not going to break everything if that's muscle memory for you, is for me at times, but that's basically what we were doing here. Sorry, extremely dry in here today. Okay, so we talked about MIME types here. Let's talk about caching now. Now, basically, caching is temporary storage for us, and this is baked into HTTP, which is fairly nice. Now, obviously, we were in class, we would have a discussion about what's the purpose of temporary storage, but the idea really is to reduce the amount of requests that we need to make. So I can temporarily cache information. And this could be temporarily storing, usernames, could be temporarily storing resources of any kind. Basically, we would set what type of information is it with the MIME type. We'd set how long it's going to expire. Just depends on what we want to do. Now, we can actually do this in 3 different ways. We could do it on the server, meaning that our actual web server is caching things for us, ideally to, say, speed up browsing. You can have your actual browser store information for you through things like cookies or sessions, basically temporary cache where it's going to temporarily store data for you. We also have on the proxy side as well. So if we have a web proxy that is basically proxying information to and forth so that we can easily pop between servers, for instance, we can do this as well. Things to consider here. We're not going to get too deep into caching right now, but you have to consider as the developer architect of your application, what is important to cache, when to use it, and how long to cache things for. Couple of examples for you to consider here. If you are caching, how long is something valid for? So if I'm caching a resource because let's say I'm auto-generating an image with some watermarking happening on top of it. Maybe that watermark has a date. Okay, I go to generate a new image. Does the old image still exist in the cache? Okay, and the reason why is let's say that you are a user, you access your browser, get the image from the server, and it pulls the cached version, meaning it's out of date. So it's something, example kind of like this, we'd have to say invalidate the cache, put a new image in, for instance. Other example, and this is not necessarily, like a best practice or something to do right now, but you have to consider privacy issues with cache now. There are, laws out there like GDPR where you have to tell users what you are caching, what you are storing, if it's important to them. You might start seeing this server uses cookies as a, very simple cache. Basically, the idea is you have to understand what type of data you're storing, how to store it, when to store it, how long, when is it valid, and even further these days, are there privacy concerns for you here? So, I hit the wrong button on my mouse. That's what happened there. Let's talk caching headers. So with the various versions of HTTP out there, HTTP 1.1, we have some designators for cache control. So this would be a header you would send. Is it public? Is it private? Is there no cache? So this resource, whatever it is, web page, image, whatever, it can be cached. It's public. If it's private, it can be only stored in a specific cache, right? Only one particular entity is allowed to access this resource. Let's say that I have two users browsing to my web server, and I have a private cache set up. User A can't access user B's cache, for instance. In HTTP 1.0, all we would really set is a pragma statement for no cache, meaning don't cache this resource. HTTP 2, we have other examples as well. Now, for HTTP 1.1, okay, so here's a bit more detail on cache examples for HTTP 1.1 and beyond. This is this image is from web.dev, which is a Google-fronted resource. Basically, this is going to be pushing the frontiers of the web, progressive web apps, things of that nature. We talked a little bit about PWA before. But information about our cache, how long is it active for? Is it private? Is it public? Are we not allowed to actually cache this resource? Plus, other designators as well. Okay, one of the other header tags that we had were Etags. Now, this is basically a identifier for a very particular version of a resource. So again, think of a resource as an image, HTML file, a script, anything that your server needs to host. If I have a very specific version that I want to access, I provide an E-tag for this. So if we, again, look here at our headers, we had an E-tag somewhere, I remember seeing. Where are you at? Where'd you go? Yeah. Oh, okay. I had to click the Sorry. Okay. A lot of cutting in this video. I'm sorry. I was having issues with mental issues, I guess. But let's say I click a random resource in here. Okay, so here is scripts.js version equals 5.1.6. I have an e-tag here that specifically references this resource. All right, so effectively, if you see an e-tag, it's not something that you're necessarily setting manually. You can if you want, but this is going to be related to your caching. So is this reusable? No, we're not storing it. Is this response or this resource reusable? Yes. Do we have to revalidate it every single time? Yes. No cache because we need to regenerate this thing every single time. If we don't have to revalidate it, is it cacheable? No. It's private. Yes. Public. Do we have a lifetime? Yes. What's its age? Set it. Add an e-tag header. Now we have a way to easily access this particular resource header. All right, so I have a little bit more detail here as well. Again, this is something kind of used by our HTTP protocol to break down resources and retrieve them and things like that. But that's kind of how it works behind the scenes. All right, this video is getting a touch long. So what we're going to do is we'll take a break here with security, and I'll be back in the next video. Everybody.